exponents. Exponent or index. If x is multiplied for 7 times, x into x into x into x into x into x into x is written as x to the power 7, read as x raised to the power 7, and x is base 7 is called exponent. 1. Product law is equal to a to the power m into a to the power n is equal to a to the power m plus n. 2. Quotient law is equal to a to the power m upon a to the power n is equal to a to the power m minus n. 3. Power law a to the power m to the power n is equal to a to the power m into n. 4. A into b whole n is equal to a to the power n into b to the power n. A upon is equal to a to the power n upon b to the power n. 5. A to the power 0 is equal to 1. X to the power 0 is equal to 1. 5 to the power 0 is equal to 1. 6. A raised to the power minus m is equal to 1 upon a raised to the power m. 1 upon a raised to the power minus m is equal to a raised to the power m. 7. Under root a is equal to a raised to the power 1 upon 2. 3 radical a is equal to a raised to the power 1 upon 3. M radical a is equal to a raised to the power 1 upon n. Power of a quotient property. For any small n belongs to capital N, a upon b whole raised to the power n is equal to a raised to the power n upon b raised to the power n, where a and b belongs to capital R and b is not equal to 0. By the definition, a upon b whole raised to the power n is equal to a upon b into a upon b into a upon b up to n times is equal to a into a into a into a up to n times upon b into b into b into b up to n times. Definition. For every small n belongs to capital N, x belongs to capital R, x not equal to 0, we define x raised to the power n is equal to 1 upon x raised to the power minus n. By the definition, division property can be written as follows. In the first instance, for any m or n belongs to capital N, m not equal to n, x belongs to capital R and x not equal to 0, x raised to the power m upon x raised to the power n is equal to x raised to the power m minus n. If m is equal to n, then x raised to the power m upon x raised to the power n is equal to x raised to the power m upon x raised to the power m is equal to 1. X raised to the power 0, which is equal to 1 by the case second of property. Therefore, x raised to the power 0 is equal to 1 for every x is not equal to 0 and belongs to capital R. Note, when x is equal to 0, no meaning is assigned to x raised to the power 0. If x is not equal to 0, x raised to the power n into x raised to the power minus n is equal to x raised to the power n minus n is equal to x raised to the power 0 is equal to 1. Implies that x raised to the power minus n is the multiplicative inverse of x raised to the power n. That is, x raised to the power minus n is equal to 1 upon x raised to the power n. So far, we have discussed exponents which are integers. We shall now take up exponents which need not be integers. Consider 5 raised to the power 2 is equal to 25. We say that 25 is the square of 5 or second power 5 and 5 is the square root of 25 or second roots of 25. Similarly, in 5 raised to the power 3 is equal to 125, 5 is cube root of 125. If a is a real number and n belongs to capital N, also greater than 1, then the number x such that x raised to the power n is equal to a is called the nth root of a and is written as x is equal to n radical a or a raised to the power 1 upon n. In the expression, n radical a is called a radical, n is called the index and a is called the radica. Since n is greater than or equal to 2 and most of our computations relate to square roots, we usually omit 2 from 2 radical and we simply write under root. We know that the square of positive integers or a negative integer is always a positive integer. For example, minus 3 whole square is equal to 9 and 3 square is equal to 9. Thus, every positive number has two square roots, one positive and another negative. We use under root 9 to indicate the positive square root of 9, while minus under root 9 to indicate the negative square root of 9. If a is greater than 0 and n is any positive integer, then n radical a is positive. If a is less than 0 and n is any odd integer, then n radical a is negative. If a is less than 0 and n is any positive even integer, then n radical a does not exist in the set of real numbers. Extending the law of exponents, observe the following examples. 8 raised to the power 1 upon 3 into 8 raised to the power 1 upon 3 into 8 raised to the power 1 upon 3 is equal to 8 raised to the power 1 upon 3 plus 1 upon 3 plus 1 upon 3 is equal to 8 raised to the power 1 is equal to 8. That is, 8 raised to the power 1 upon 3 whole cube is equal to 8. Therefore, 8 raised to the power 1 upon 3 is equal to 3 radical 8. 2. 3 raised to the power 2 upon 3 into 3 raised to the power 2 upon 3 into 3 raised to the power 2 upon 3 is equal to 3 square. So that 3 raised to the power 2 upon 3 into 3 is equal to 3 square. That is, 3 raised to the power 2 upon 3 is equal to 3 radical 3 square. By the observation made in the above example, we can define x raised to the power p upon q is equal to q radical x raised to the power p, where x belongs to real numbers, x is greater than 0 and p upon q belongs to real numbers. Clearly, x raised to the power minus p upon q is the multiplicative inverse of x raised to the power p upon q. X raised to the power p upon q into x raised to the power p upon q is equal to x raised to the power 2p upon q. X raised to the power p upon q whole raised to the power m is equal to x raised to the power mp upon q.